Okay, I decided, I've been kind of poking around a little bit and not really getting anywhere. So I have decided to put my leads here on the from my other scope on the inputs to kind of get a better view of what's going on here. And this is what it looks like. The bottom line looks great, and the bottom line, the red line, is actually buffered address 12. So, you know, the address bit is great. The top blue line comes off of the 139. Right here, this 139. Line 4. I'm on this guy right here, 5R. So I'm going to analyze this 139, and I want to see what this looks like. Because I would think that that should be a low pulse right there, and it's just kind of a low little spike, and then it's kind of got some nonsense going on over on the other side. I'm kind of thinking I want to just hit run UUT. Yeah, I don't know what's going on. See? When you do run UUT, that is not going to be a low output at all. But if I just do a look, try to read from a RAM location, let's go 0010, that's RAM, loop it, and I'm getting this nonsense. I don't know. It seems like those should both be low at that pulse. To activate the RAM. So I'm going to go ahead and analyze this and just make sure that it's looking good to the system. Because that's what the analyzer will do, is the analyzer gives you a look at what the system actually sees. You know, it takes the waveforms out of it. Because the system is all about ones and zeros, period. So the analyzer will give you a definite look at what the system is looking at. So we're going to have to do that. We're going to have to go ahead and analyze this guy and make sure it's doing what it's supposed to be doing. Not this guy, but the 139. That creates this top signal. I kind of think it's going to be just fine, because if I run run UUT, it's got a nice signal, a nice low pulse there. So it's like something's funky with this. What is going on? And it's just address bits, see? It's just address bits that are doing this, and I know that the address buffers are good. I don't know. Mystery right now. But we'll move along. All right. I have removed and socketed all of the RAMs because I wanted to isolate them off of the data bus. And I never hate it when I put sockets in, because sockets are good for memory, right? That doesn't have anything to do with anything, though. I've tested all of these guys and they're all good. This is not a RAM issue. And I have found the problem. I was looking at this guy. And you know what, maybe I should be looking at this guy. Hold on a second. Hold the phone. Yeah, never mind. This is being enabled because I'm triggering these two guys right here, and the you know, the 8 bits from these two RAMs are this buffer. The 8 bits from these two RAMs are this buffer. So yeah, different. Alright, back to the drawing board. So this guy is being enabled. The data comes out and goes to here. These two signals seem to be good. You got 8 bits low, 8 bits high, basically. So I'm going to have to do some more probing around. I thought I was onto something, but I'm not. So I'll be back. I'll keep looking, keep probing. Okay guys, these two RAMs are the ones that I'm questioning. These ones, I don't know. I'm not worried about them right now, these two. This buffer right here, pin 19 is this signal, DRL not. Right? DRL not. And that comes from this guy right here. DRL not and DRLH. 11 and 10. I'm going to run the UUT under test. Just run it. And I want to probe the outputs of this guy on 6L and just kind of look at it. It's this guy right here. That is pin 10. That's DRH right there. This is DRL, which doesn't look right to me when it comes down. Now it doesn't want to do anything. And then this is the only one that really looks normal. Look at this, kind of floaty. This one doesn't seem to do much. That's data bus. You know, I don't know. I mean, it could be totally normal. But I think it's a good way, a good place to go is to pull this guy and see if it's any good. It's an 82S129 bipolar. So we'll take a look at this guy. And see if it's doing what it's supposed to do. Alright, let me stop this. Stop. I found something very strange. If I take, let's stop this. Let's go to, oops, this guy. And let's just run this repetitive. This mux right here, select line, does this, right? This is always enabled. Line 5 is high all the time. Line 6 is high all the time. But look at the output. The output does this. Now if this thing is selecting between two high lines, it should stay high, right? Normally you can get away with something like this if it doesn't go below the threshold of being a low, right? Now look at this. Okay, this is where I was just probing, pin 7 of this guy. These RAMs work, right? But if I try to do the other RAMs, it doesn't work. And I'm wondering if this data bus right here, which goes back to the CPU, is getting corrupted by this thing, because this pulses. This static RAM high, I'll show you pin 19. It comes from static RAM high, comes from 6A pin 3. Oh, that's way over here. 6A pin 3. Okay, see that? 6A pin 3. And honestly, I'm wondering, is that even supposed to do that? No, it's not. You know what? And I'll tell you exactly why. I'll tell you exactly why that's doing that. That should be high all the time until you're trying to get to the static RAM. The reason it's not high all the time is because this pulse that we just looked at is coming out and going up here, and it's registering as a pulse, so that's why this is pulsing. Yeah. But anyway, yeah, that's making this, which is what I'm on right now. This guy right here is what I'm on with the analyzer. And you'll see okay, this pulse that's not supposed to be there is coming into here, and when I try to do a write, it's output enabling these, which has got to be corrupting this data bus, because this is also always pulsing. This will work because when you try to access these, the pulse gets really wide, so it doesn't affect when you're trying to write and read from these guys. But when they're not being accessed, this pulse train is coming in and it's corrupting this data bus. I know that's what it is now, because we'll take a look at this guy right here. This is 7H. That's this chip right here. Okay. And I'm going to switch over to my analyzer. And I've got a snapshot right here of when I was trying to read and write to location 0, which is the dynamic RAMs that I have a problem with. And you'll see this pulse right here. This pulse right here. See all these little pulses? That's that mux. And when this line goes low, that's this read-write line, which is, you know, used all over the board. And when that goes low, it's sending a pulse right here that's coming down and enabling the output for these guys, which I guarantee you is corrupting this bus. I'm not guaranteeing it, but that's my theory right now. Because this is set at 500 nanoseconds. That is clearly being recognized as a pulse to the system. Yeah, and I've already looked in both of these guys right here. I'm going to replace all three of these because all of them are slow like that. These three muxes that are right here, 1, 2, and 3, these guys, I'm going to replace all three of these because they're all slow like that and allowing leaking pulses through. So, yeah. I'll go ahead and do a let's do a let's write to location 03. Let's write, it doesn't matter, and then loop it. And now let's do, see how it's doing that? This is consistently running accumulations on. Turn that off. But see that? This is running non-stop. You got that right pulse, and then it's right in that, right there. See that pulse right there? Yeah. That's not supposed to be there. That should be a high line. Static RAM is not supposed to be being accessed. So I'm going to go ahead and replace these three guys right here, these 157s. Yeah, see, it's data error. Let's go ahead and clean that up. Okay, so I did replace those 3 guys, and I am hooked just up to line 7. Remember, that was showing the pulses. Now this is running and you're getting no pulsing. But let me stop this and we'll go over to this guy and throw this guy on here. Pin 7. Oh, repetitive. You'll see it still has the little lines, but it stops short of the threshold of being low this time, which is what it should be. It should not register as a low, and now it doesn't. I mean, this is still not as clean as I would like to see it, but it's better than it was. It definitely was sending errant pulses before. So even though this did not fix my ultimate problem, it did clear this up, which I am happy about. Now we'll stop this and go back to Logic Analyzer and go ahead and run it repetitively, and you see it's nice and clean. Now if I do a write at 8,000 and loop it, okay, let's do a RAM short 8,000 to 87FF. 8,000 to 87FF. Okay, why is that not doing anything? Do I have the right line hooked up? I do, 0. And let's go back to format. Pod 1, line 0. It's showing that it's moving right now. Waveform. I don't know. I guess let's trigger on it. Maybe that one's 88. Let's go RAM short 88 to 8FFF. Yeah, there it is. Okay, that's the wrong range is all. So now we're getting now you're getting the pulses, and once this RAM short completes, that will go to a straight line. Still going. Yep, and now it says okay. And I'm going to hit stop. Bus test. Why is it still going like that? Come on. Oops. Repetitive. I'm going to do this again. Let's write at 88. Loop. Okay, why is that not? How about write? There it goes. You see that? Yeah, it's just, you have to actually trigger on it. Yeah, that's all, I guess. Anyway, anyway, bottom line is, it doesn't send errant pulses anymore with new chips in it, so I'm happy about that. It didn't fix my problem, but next thing I'm going to look at is dynamic RAM address decoding. I think there's 153s right here that provide the address. These four guys right here provide the addressing to these guys, and I have not analyzed these, so I'm going to do that. I'm going to analyze each one of these guys and make sure that our addresses are proper. So that'll be next. I am glad that I replaced these. It cleared that up. There's no more errant nonsense going on, so that's a good thing. So next thing is these guys. Alright guys, I analyzed these four 153s, and one of them was bad. This guy right there was bad, and I do have a little Patreon video showing this chip being bad. I've got the fluke hooked up to it, and check it out. There it goes. Now, really, these three chips right here that I replaced, you remember how they were causing those errant pulses? That would be an issue. I know it. I guarantee that would be a problem, because it was, the system was seeing that as pulses, and it was causing that 32 to send errant enables to these RAM, the whatchamacallit RAMs, the two 6116s. So yay for catching that. But let's do, I mean, it's obviously fixed, it's running. So yeah. You know what's funny is I turned the board on and it just started running. I didn't do anything with the fluke. It's running without it even, I didn't do anything. I didn't touch anything. I had the fluke turned on, I turned the board on and it started running without me even hitting run UUT. So yeah, I don't know what that's all about. Weird. But there it is. Rolling. And now we can do our RAM short 0 to 7 FFF, I think. And it just says, okay, let's do it again. Active force line, setup. See, I didn't even do anything to this thing. Okay, bus test. RAM short 0 to 7 FFF. Run UUT. Okay, this is weird. You know what I'm going to do? Let's do this. Let's turn the fluke off. Let's turn that off. I'm going to remove the fluke and put the CPU in it. I'll be right back. Yeah, I removed the fluke, put the CPU in the board, and it just wasn't digging the fluke for some reason. But it's going. So I think what I'll do is I'll plug in the trackball and see what we get. Alright, I took some time to wire in coin and player 1 start, jump. You know, player 1 start is jump, so I got my trackball hooked up, get the game rolling. I'm gonna set the tripod up and we'll play a game of Crystal Castles. Okay, we are all ready to go. So I will coin up and give this thing a shot. And the coin is in. Gotcha. Oh, jerk. Stupid skeleton. Oh no! Oh. Oh. Take that. Oh, we're running. Take that. Stupid tree. No! Must be a lot of guys set on the dip switches. Ba, 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 ba. Yeah, these are the high scores are saved. All right. All right. that? Crystal castle's fixed. And I know that we fixed a future problem, if not a current problem, with those 157 multiplexers right here. Those guys right there just were not, they were showing low pulses, and they shouldn't have been. So, very happy about fixing that problem. This guy was really the main culprit. I did lift these, so I mean that's cool to have these socketed now though. So yeah, we found that was definitely an issue. This one was flat out wrong. I lifted this guy, socketed it, and tested it out, and it was fine. So it's always good to have that stuff socketed, you know. So yeah. All right. Cool. I'll let this one go for a while, and as always, guys, I appreciate it. Like and subscribe and all that good stuff. You know what to do. I appreciate it. Thanks, guys. And we will see you on the next Classic Arcade Repairs. Peace out and goodbye.